Now let's see the next type of dependency. It is called as control dependency. Control dependencies or control hazards. So the name control dependency is because this type of dependencies will arise whenever the flow of control becomes unpredictable. So if you see, there are certain types of instructions. One is conditional branches, conditional branch or conditional jumps, okay, and the second one is unconditional branches, and the third one is function calls, and the next one is program control instructions that may affect program counter. So these are the four types of instructions because of which we may not be able to continue the program in a sequence, which means the next instruction to be fetched may not be the one in the sequence, in the sequential order. The order may vary. So you know what is a conditional branch is. We are going to test some condition, and if there is the test happens to be true, then we are going to branch to some other location. So we have to leave from the present instruction and go to the next instruction, which is not a continuous sequence, and we have to execute it. And you know what is unconditional branches. These two are actually bit different, because in case of conditional branches, we don't know whether what is the target instruction until we execute the condition. In case of unconditional branches, we need not know we did not go till the execution phase. If the instruction is known to be unconditional branch, then directly we can find out the branch address. And the next one is function calls. Function call is also a kind of and along with that function calls, you can also make the return also. So return is also a kind of branch. Whenever we call some function, we have to go to some other location, execute it. Similarly, program control instructions that may affect the program counter. So we have seen that when we are discussing about some basic example of a computer design, there we discussed about one instruction, if you remember, skip if 0 or skip if 1, something like that. So we are going to skip the instruction based on some flag, skip if 0 flag, skip if carry flag, like that. So based on some condition, we are skipping the instruction. They are also they have affected the program counter, right? Because we have incremented the program counter. So anything that actually affects the program counter can be considered as a branch type of instruction. Now because of such branch type of instructions, our main aim will not be able to achieve that aim. So you know the main aim of our pipelining. The main aim of the pipelining is to have clocks per instruction as 1, CPI as 1, right? So this is our main aim, right? See, there are various ways they can ask you the questions. One is they might ask you what is the clocks per instruction, right? Sometimes in the options you might even see, even though clocks per instruction is 1, they might ask a different question like what is the throughput. So throughput is nothing but, in case of pipelining, throughput can be, you can consider throughput as number of instructions per second, number of instructions that have been executed per second. How to convert this CPI equal to 1 to some number in throughput? See, this topic is not related to this one, I just remembered, that's why I'm telling you here. Sometimes they will ask you this in the exam. So CPI, we know that it is 1. How can I convert CPI to throughput? So throughput is nothing but number of instructions that can be carried out in 1 second. Try to understand this. CPI is 1 means in 1 clock I can finish 1 instruction, right? Let us say this one clock happened to be, for example, 1 microsecond. right? What does it mean? In 1 microsecond, one instruction can be executed. Then in 1 second, how many instructions can be executed? 10 power 6 instructions, right? Therefore throughput is nothing but 10 power 6. Why? Throughput is these many instructions per second, therefore throughput here is 10 power 6. Got it? Okay, now let's come back to this topic. Yeah, we are talking about the conditional branches, this control dependency. So whenever there is a conditional branch or unconditional branch or any kind of branch instruction, we will not be able to achieve our goal. So what is the goal? To maintain CPI equal to 1. Now what is the problem? Why this is happening is, you can think of it this way. Let's take an example. Assume that we have a pipeline in which we have 5 stages. So stage 1, stage 2, stage 3, stage 4, stage 5. So we can take few instructions and try to execute and see what happens. So this is first instruction, okay, and the second instruction is going to be like this. S1, S2, S3, S4, S5. This is clock 1, clock 2, clock 3, clock 4, clock 5, clock 6, right? Now assume that this second instruction happen to be a branch instruction, okay, some kind of conditional branch, and we don't know whether let us say this instruction is 100 instruction and this instruction is at address 101, and the next instruction depends on the output of this one, right? Therefore the next instruction can either be 101, 102, or it can be 200. Let us say 200 is the target instruction. Assuming that this particular instruction, which is present at address 101, is a conditional branch instruction, and it can either branch to 200 in case if the condition happens to be true, and if the condition happens to be false, it will continue with the sequence, right, the successive instruction. So assume that this is an instruction in which the branch is going to happen, which means the condition happens to be true. Then what happens? So we don't know at this particular clock which instruction to fetch, but our program counter will be 102. Therefore the next instruction that will be fetched is 102 itself, right? So it will be fetched, so it will start executing S1, S2, S3, S4, right? And then 103 will be fetched, right? It will also start executing. It will finish S1, S2, and then S3, and then 104 instruction will also be fetched, and it will be also in the pipeline under processing S1, S2, and then 105 will also be fetched. It will also start processing, right? So S1. So now if you observe it, by the time we know what is the next instruction after the instruction 101 at this time at clock 6, let us say here we found out that the next instruction has to be 200. By that time we have actually fetched and completed all these instructions, right? Now what should we do with this? We have to flush all this, that is called as flushing. Flushing the entire pipeline with whatever instructions we have done, which means whatever instructions we did and whatever effects they have. Let us say they have affected some registers, and all those registers have to be restored to their before values. We have to flush all of them, and at this point again we are supposed to start the next instruction, which is starting at address 200, right? So if you observe it, by doing so we are actually not able to get the next instruction in the next cycle, right? So this cycle we are not going to get anything. Similarly, the next cycle we are not going to get anything. Next cycle we are not going to get anything. So whenever such branch instructions are present, we are actually losing some of the time, and we will not be able to achieve CPI of 1, right? So that is called as penalty or branch penalty. So whenever we have a branch instruction, we have to undergo some penalty, and because of that penalty our CPI will not be 1, it will be roughly more than 1. We shall analyze how much this CPI is going to be. I hope you understood this, right? So whenever there is a branch, we'll have to flush the pipeline, right? This is one method. And sometimes people say that there are various methods. Okay, one more thing, how can we deal with this? There are various things people have come up with. One thing is, let the pipeline finish, and whenever at the end it finds out that we are done with the wrong instructions, then we are going to go with the flushing, right? And the second solution is, we have to design the processor in this pipeline in such a way that it should be able to detect that it is a kind of branching instruction, probably in its S1 or S2. Let us say in S1, it has to find out that it is a kind of branch instruction, and since we don't know which instruction to fetch after this, we have to stall, right? Stall means stop the pipeline from taking the remaining instructions into the pipeline till that one is over, right? That is called as stalling the pipeline, or leaving it empty, right? And the third one is like, there are various solutions, right? And the third one is like, you can continue with the instructions, but our compiler, whenever there is a branch instruction, since we don't know what will be the output of the branch instruction, till we know that point, implement, you insert the instructions no op, which means no operation, right? So in this case, how many no ops should be this inserted? 1, 2, 3, 4, right? So if you have anything like this, if you have branch on 0, right? To branch on 0 is a conditional branch, and you are supposed to branch on 0 to 200. If this is the instruction at address 100, then according to this third strategy, where compiler is supposed to introduce some no op instructions in the consecutive locations 101, 102, 103, 104, it is supposed to insert no op, and then at 105 some valid instruction should be there. So by doing this, compiler, if it does it, then what happens is, by the time this particular instruction at 101, let us say this is the instruction at 101, this particular instruction at 101, by the time it finishes its all these stages, whatever we did here, all these are useless instructions. No op means they will be fetched, they will be, processing will be done, but they are not doing anything literally, right? So by doing this, introducing this no op, we are not actually doing flushing, or we don't need any support from the hardware. Our compiler should be smart enough in order to recognize such a kind of branching, and it should be able to introduce all this. So by doing this, the entire burden is pushed onto the compiler software. So we need smart compilers to do this, right? And also we need smart compilers to reschedule or rearrange. So reschedule or rearrange means, in these parts you try to move some of the operations here. So either from here you try to move some instructions, or from here you try to move some instructions there, right? So it is better that you move some instructions from here to here, so that whatever instructions, if let us say there are some instructions, either if you execute it here or here, does not affect this particular instruction, then you better move those instructions here and keep on executing those instructions till this particular output is going to be known. And for that also we need a smarter compiler, and it is being implemented in most of the compilers. So what is it? Our compiler should be smart enough in order to fill these gaps with some instructions whose movement does not affect the outcome of this, or whose movement does not affect the program as a whole. If you can find out such instructions and if you try to move them, then we can use this efficiently. Are you getting this? So in order to avoid the penalty, only solution that we have is rearranging the instructions. Whatever other things that you do, everything is going to we cannot eliminate the penalty at all, I mean completely. So either you do flushing, it is waste of time. You introduce stalls, we are wasting the pipeline. You introduce no op, we are again wasting the pipeline. Only thing that we can go with is rearranging, right? So now let's try to eliminate. So if once you understood this, these are various ways we can handle this control dependencies. Now let's try to find out what will be the CPI, what will be the effect on CPI, how much the CPI is going to affect based on the number of stages and the number of instructions in the program which are actually this branch type. We shall try to derive something and later we shall see some problems on it. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay, IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.